Hello fellow problem solvers. So today we're going to be doing a problem from the 2014 Junior Balkan Math Olympiad, problem number G6. I suggest you try this problem out for a minimum of 45 minutes, ideally an hour and a half to 2 hours, but not more than 3.5 hours. If on the other hand you'd like to go along with us, I suggest you take 20 minutes and put your first ideas out on paper. Maybe even take 30 minutes and put your first ideas out on paper, draw a diagram, see what it is that these conditions can tell you about what it is you could prove. So now, without further ado, let's begin. So this is the problem. We have that AB and CD are not parallel, and that AC and BD don't intersect at a 90-degree angle. We have these two midpoints, we have these two orthocenters, and what we need to prove is that MN is parallel to H1, H2 if and only if AC is equal to BD. Now the reason I'm showing this problem is because it's really 1 to 2 maybe ideas, and it's a cool idea. So first thing, what's generally useful in competitions is that you write down everything you know about the problem. So for me, when I was doing this at a practice exam, I took the midpoints of AD and BC, let those be S and T, and then I know, because I have these midlines, I know that SNTM is a parallelogram, and because AC is equal to BD, we have AC is equal to BD if and only if ST is perpendicular to MN. Now the thing for me is I just wrote this down. I didn't solve the problem at the practice exam, but just writing this down got me a point or two. So the first sort of instructive thing is when you write stuff down on competitions, when you have ideas, you write them down so that you may get partial points if you don't have anything else. Now a natural question is, how do you connect H1 and H2 together? Like, how do you connect M and N together is one thing, but also H1 and H2, like how do these even connect? How do they connect to the points T and the point S? And here I invite you to pause for 20 minutes and ask yourself, how do T, S, H1, and H2 connect to each other? And the answer is, well, let these be the feet of these perpendiculars, D1 and C1. Is there anything new you see now? And I just want to point out before I continue that for the record, if you wanted to solve this using coordinates, it would be tough, but not impossible. And you would need a lot of concentration to be very, very good at algebra so that you don't mess anything up. Because what you need really, if you're going to go down that route, is if you had points XA, YA, point XB, YB, and XD, YD, then you would need to know what is the intersection between these 2 points and these 2 points in general. You would need that to get H1 and H2. And that's difficult. Like, you would put O to be 0, 0, then you would have A, C, B, and D be somewhat normal. And then you would need to go ahead and try to figure out H1, H2. It's a complicated expression. And then you could get somewhat, and then the intersection thing is this parallel condition is also not that difficult, but actually, what am I saying? It is quite difficult. You would have degree 3 or 4 the last time I checked. To have AC is equal to BD, that would be of degree 2, and then you'd have a degree 4 equation here. So I don't know how you would do it, but it is doable. But now back to the main idea. So T is really the center of a circle through A1, D1, D, right? That's what T is. And S is the center of the circle through B, B1, C1, C. That's what S is. So now we know that everything on the radical axis of these 2 circles, and what's the radical axis if you have 2 circles? It's the set of points which have the same power of point and the same type of power of point with respect to the 2 circles. And they lie of the line that's formed by the intersection of the 2 circles. And we know that if we take the centers of these circles, O1 and O2, we have this and we have this. So we know this is a kite, which means 001 is perpendicular to the radical axis. And this is always true. So now here, we know ST is perpendicular to the radical axis of these two circles. And now, as you can see by my picture, I'm claiming that both H1 and H2 are on that radical axis. This is the main idea of the problem. I want to say it's an insane idea. It's absolutely creative, wild, but this really solves the problem. And now I will give you about 5 to 15 minutes for yourself to see if you can solve this problem with this idea. And the only way I can really motivate this idea is that proving ST is perpendicular to H1, H2, proving this immediately proves this. So that makes sense to look at this as your problem condition. And then what you have is you have a circle with a center that T and a center S, and it contains these points which make up the orthocenters. So that's sort of the logic behind why you would look at the radical axis. But anyway, now it's really just noting that H1A1 times H1A is equal to H1B times H1B1. And this is because these points are concyclic. And now with this in mind, this is the power. Let's call this the circle with center O. So let's call it CT with center T. This is the power of the point H1 with respect to the circle CT, H1, A1, and it's an internal power of point. And this is the power of points of H1 with respect to the circle CS, circle with the center S. And this really shows that H1 has the same power of points with respect to both of these circles, so it lies on the radical axis. And by pure analogy, H2 also has the same power of point. And that really solves the problem. And now let's move on to a solution. So I would invite you here to really take 5 to 20 minutes and try to write up a solution. The first step is let S and T be the midpoints of BC and AD respectively. A1, B1 feet of perpendiculars from A and B to BO and AO. Similarly with C1 and D1. And now with this, the first thing we do is we prove that SNTM is a parallelogram. And the way we do this is by using the midlines, namely from the midlines. From midlines we have this, which makes SNTM a parallelogram. And we have that with the sides BD half and AC half. And from here, what we can say is that AC is equal to BD if and only if SN is SM, and this is true if and only if ST is perpendicular to MN. This is true because this is a parallelogram property, though we can prove it is by going in both directions, namely if this is true, then we prove that. So if this is true, we have SN equals SM is equal to TN equal to MT, so this is a kite, we're done. Otherwise, if these are perpendicular, we know that if this is the intersection, this perfectly divides this. This is the midpoint of ST, and then we have a triangle congruency, which implies this is equal to this, but because this is equal to this, that implies SM is SN. And finally, with that, what we're going to prove is that ST is perpendicular to H1, H2. And this completes the problem. And the way we prove this is let CS be the circle with center S and diameter AD, CT the circle with center T and diameter BC. We have the power of the point of H2 with respect to CS is equal to this, is equal to the power of H2 with respect to the circle CT. The power of H1 with respect to CS is equal to this, is equal to the power of H1 with respect to CT. And now this right here implies that H1, H2 is the radical axis of CS, CT. And this here, right now, implies what? Well, it implies that H1, H2 is perpendicular to the centers of CS and centers of CT, which are what? S and T. And now with this, we connect it all together. And what we have is AC is equal to BD if and only if SN is SM. If and only if ST is perpendicular to MN, if and only if H1, H2 is parallel to MN, which is what we needed to prove. And as always, thanks for problem solving.